Welcome to Chapter 3. We're going to be practicing doing derivatives the easy way. So first off, we need to make sure that we rewrite things properly. You can't take the derivative of x squared in the denominator. We're going to have to rewrite the functions, learn to rewrite the functions. 2x to the negative 2, the derivative would end up with x to the negative 3, not x to the negative 1. Also, 2 in the denominator is not 2, it's a 1/2. So, watching for that. This is t to the negative 5/3. Notice we're not trying to take derivatives at this stage. I'm just practicing rewriting things right now. Speaking of which, it's going to be much easier to deal with simplifying if you write your fractions vertically. Okay, canceling down, we have 1. This ends up with the 2 and the x squared in the bottom. X and 2 end up on the top on this. I'll put the 2 first. And you have a leftover x. Now again, this is not ready to take the derivative. You have to prep it for surgery. That's not a 2. It's not a 2, it's a 1/2. So I'll write a little note in blue. It's really a half, not a 2, so make sure you're not adding 2x to the negative 2. Okay, derivative. If it's too simple to have an exponent, just think slope. The derivative of x is 1. The derivative of 7 is 0. So remember there's 2 notations for derivative. I'm going to mix up some of them. Speaking of which, here's the other notation. I need to rewrite 2 over x first. One thing people do is that they accidentally start taking the derivative and then try to simplify the other term. Make sure that you're simplifying the other term somewhere else. This is 2x to the negative 1, so the derivative is negative 2x to the negative 2. So remember, when you take and you subtract 1 from a negative, it gets more negative. So I'm going to rewrite this first. My suggestion is rewrite it in line with the original. It's not a 2, it's a 1/2. That's another 1/2. Okay, so the derivative is negative 1/2. Let's see, h prime. We often don't bother with the of x because we're lazy butts. Pop the negative down in front, subtract 1 to get the new exponent. And then the second one, the derivative is just 1/2. So notice that x in the denominator and x in the numerator have very different derivatives. Okay, this is f of r, so this is going to be df dr. Pop the 3 down in front, it cancels with the 1/3. Derivative of the volume is the surface area. Coincidence? Not for circles. What is this? Don't forget to set it in line with the original. T to the negative 5/3. Negative 5/3 minus 1 is not negative 6/3. You have to rewrite this as x to the 5th. So the derivative, oh, why did I have h of t? H of x is x squared times x cubed. Derivative is a 5x to the 4th. All right, on the back side, we've got the function negative x squared plus 2x plus 8. I'm going to factor it. We factor it by first factoring the negative out, because people suck at factoring when there's a negative in the leading term. Let's see, we need -4 and +2 to get a negative in the middle. So okay, so -2, 0, 4, 0. The vertex that symmetry that the vertex is halfway between the intercept is not true in general. It's just quadratics. So this is going to be at 1. The other way you can do it is minus b over 2a. And that's also 1. So it's 1 comma what? Plug in 1. The negative of 1 squared is -1. So that's 9. Down 1, down 3, down 5. Yep, that worked. Okay, good. Find the derivative. Okay, so the derivative is 0. Here's the idea. Add a max or a min. The derivative is 0 98% of the time, but occasionally you get something like absolute value of x, which has a min at 0, but the derivative is not defined. But it can't be positive or negative. It's just got to be either 0 or undefined. So just a little note. Take the derivative, set it equal to 0. I'm going to say, by this time in 2 weeks, you'll be able to say that all in one word. Take the derivative equal to 0. Yes. Because that's what you do with derivatives a lot. Not always, but a lot.